Hello dear students, and welcome to a new statistics lesson, and today we'll be talking about the dispersion. Let's now see the dispersion measurement. The first one we have is called the range. The range is also called the simplest measure of dispersions. The range is the difference between the greatest value and the smallest value in a set. Example 1. The first set has values 51, 53, 55, 57, 58, and 60, where the second set has values 42, 45, 47, 49, 52, and 92. And the question here is asking us to compare the two sets above. As you can see here, that the range of the first set is the biggest number minus the smallest number, so it's 60 minus 51, which is 9. And the range of the second set is 92 minus 42, which is 50. The result of that, you will see that the second set is more divergent than the first set. Number 2, the standard deviation. The standard deviation is the commonest measure of dispersions and the most accurate under certain conditions, which is the positive square root to the average of squares deviation of values from the mean. Let's now see what is the formula that we're going to use to find the standard deviation. Standard deviation equals square root of the summation of x minus the mean all squared over n, where you can see now that this sigma denotes the standard deviation, x bar denotes the mean of the values, n denotes the number of values, and the summation sign denotes the addition. Let's now see how to calculate the standard deviation to a set of data. In this question, it's telling us calculate the standard deviation for the values 12, 13, 16, 18, and 21. To calculate the standard deviation, we need first to find the mean, which we call it the x bar. How to find the mean? The sum of all values over how many they are. So it's 12 plus 13 plus 16 plus 18 plus 21 over 5, which is 16. Then we go and draw this table. We put the values of x, and then we subtract the mean from every and each x value. As you can see in the second column, 12 minus 16 equals negative 4, 13 minus 16 equals negative 3, 16 minus 16 is 0, 18 minus 16 is 2, 21 minus 16 is 5. What is the 16? 16 is the value of the mean. And then we're going to square every and each result that we got from the second column to write it in the third column. Negative 4 all squared is 16, negative 3 all squared is 9, 0 squared is 0, 2 squared is 4, 5 squared is 25. After that, you get the sum of this column, which is 54. So here to find the standard deviation, it's square root of 54 over how many they are? They are 5, which is almost 3.286. Second, how to calculate the standard deviation to a frequency distribution. For any frequency distribution, the standard deviation is square root of the summation of x minus x bar all squared multiplied by k over the summation of k, where x represents the value or the center of the set, where k represents the frequency of the value or the set. Summation of k is the total frequency, where x bar is the summation of x times k over the summation of k. Let's now see how to apply this formula in the coming example. The following are the frequency distribution for a number of defective units which found in 100 boxes of manufactured units. You will see that the first row represents the number of defective units and the second row represents the number of boxes. The question is asking us to find the standard deviation to the defective units. First of all, we'll find the mean. How can we find the mean? It's the summation of x times k over the summation of k. To help yourself to find the standard deviation, let's draw this table. Where the first column, we write in it the number of defective units. The second column, we write in it the number of boxes, which is k. And then we create the third column. We make x times k. 0 times 3 is 0. 1 times 16 is 16, and so on. Column number 4, x minus x bar, which is the median. So first, we need to get the median first. How to get the median? To find the median, it's the summation of x times k over the summation of k. So we get the sum of the third column, which is 300, over the sum of the second column, which is the 100. So the mean is 3. Let's now go and continue columns 4, 5, and 6 in the table. X minus x bar. Then we square the result that we got in the first column. Then we square the result that we got from the fourth column. After that, we multiply the result by k. To find the standard deviation, it's square root of the summation of x minus x bar all squared times k, which is the sum of the last column over the summation of k, which is 100. Then the standard deviation in this case is 1.428 units. Now we reach the evaluation part. Please pause the video, try to answer the question yourself, and then play the video again to check the solution. In this question, the question is asking us to calculate the standard deviation for the next data. Question A, the values are 16, 32, 5, 20, and 27. In order to find the standard deviation, we are going to draw the table that helps us. In this table, in the first column, we call it x, and we're going to write in it the values of x: 16, 32, 5, 20, and 27. And the last one is always for the sum. If you get the sum of values of x, it will be 100. The second column is x minus x bar. What is x bar? X bar in the mean. So we need to go and find x bar or the mean first. How to find the mean? It's the sum of the values of x over how many they are. So it's 100 over 5, which is 20. So in this one, you're going to make 16 minus 20, which is negative 4, 32 minus 20, which is 12, 5 minus 20 is negative 15, where 20 minus 20 is 0, and 27 minus 20 is 7. In the third column, it's x minus x bar all squared. So it's negative 4 all squared, which is 16. 12 all squared is 144. Negative 15 all squared is 225. 0 squared is 0, and 7 squared is 49. This column, I need its sum. So its sum will be 400, 34. So, to find now, after completing this table, we're now ready to find the standard deviation. Standard deviation equals the square root of the sum of x minus x bar all squared over n. Then in this case, the standard deviation is square root of 434 divided by 5, which is approximately equals to 9.32. Question B, to find the standard deviation of the values 72, 53, 61, 70, and 59, we're going to do the same steps again. Here's the table. We're going to write x and put the values 72, 53, 61, 70, 59, and the last column is for the sum. If you add all these x values together, the sum will be 315. The second column is x minus x bar. X bar is the mean, so I need to go and find the mean. X bar, the mean is the sum of x values, which is 315, divided by how many they are. They are 5. Then, in this case, the mean is 63. So here in this column, we're going to subtract 63 from every and each value of x. 72 minus 63 is 9. 53 minus 63 is negative 10. 61 minus 63 is negative 2. 70 minus 63 is 7. 59 minus 63 is negative 4. The third column, x minus x bar all squared. So we're going to square every and each term in the second column. So 9 squared is 81, negative 10 all squared is 100, negative 2 all squared is 4, 7 squared is 49, where negative 4 all squared is 16. The sum of this column is 250. So, to find the standard deviation, it's equal to the square root of the last column over how many numbers are they? There are 5 numbers. So the standard deviation here is 5 square root of 2, which is approximately equals to 7.07. By solving this question, we came to the end of our session. Thank you very much, dear students, and wishing you best of luck.